All right, for the next thing we want to look at as far as reactions go, let me write a new reaction up here. We'll balance it quickly because you need to practice this, but you should be getting good at it. If I react nitrogen with hydrogen, the product is ammonia, NH3. And to balance this reaction, you'll notice I have 2 nitrogens on the left, but only 1 nitrogen on the right, so let me double it. That gives me 6 hydrogens, which means I need 3 of the H2s. There is a 1 in front of the nitrogen, but I don't have to write it. What this reaction literally means is 1 molecule of nitrogen reacts with 3 molecules of hydrogen to produce 2 molecules of ammonia. But we also know from our studies that a molecule is a very, very small thing, and in the laboratory I'm never going to have a molecule at a time. But a mole is just a large number of these molecules. So another way to interpret this reaction is that 1 mole of nitrogen reacts with 3 moles of hydrogen to produce 2 moles of ammonia for this reaction. This is kind of like making a sandwich. These are the parts that have to come together to form this product. One of the parts is the nitrogen, 3 parts of hydrogen, and I end up with 2 parts of ammonia. And this is what we call the stoichiometry of the reaction. You should practice this word because it's really fun to say, stoichiometry. The stoichiometry of reaction refers to the balancing coefficients in the sense that that is the relationship among the reactants and the products for that reaction to take place. From this stoichiometry, I have some equivalences. In this reaction, 1 mole of nitrogen equals 3 moles of hydrogen for this reaction to take place. I can write a couple of other equivalences. Let me put them all down. These equivalences work for this particular reaction. If I have a different reaction involving nitrogens and hydrogens, I will have a different stoichiometry. It'll be balanced differently, and so I'll have different equivalences. But these equivalences allow me to convert between the parts of this reaction using a unit conversion method. For example, how many moles of ammonia would be produced if I had 10 moles of hydrogen? All right, let's get some space and let's work this problem. I want to know how many moles of ammonia would be produced if I have 10 moles of hydrogen. In this particular reaction, my question mark is moles of nitrogen. I'm given the 10.0 moles of hydrogen, and I need a 1-step unit conversion. I need moles of hydrogen on the bottom to cancel. I need moles of ammonia on top to be left with it, and the numbers that go here are the numbers that make them equal, and that would be this bottom unit conversion. There are 2 moles of ammonia for every 3 moles of hydrogen. I don't have to write it out every time because all I have to do is look at the reaction. The 2 goes in front of the ammonia, the 3 goes in front of the hydrogen, and all I have left to do is to punch it in my calculator and round it to 3 sig figs. So I would be able to produce 6.66 moles of ammonia starting with 10 moles of hydrogen. You may notice there's an assumption here. I can't produce ammonia with just hydrogen. I also need nitrogen, but this question doesn't indicate anything about the nitrogen. The assumption is anything that's not mentioned in the reaction is present in enough quantities to get the reaction finished. So assuming that I have enough nitrogen, how many moles of ammonia would be produced if I have 10 moles of hydrogen? That's the way that these are always interpreted as far as assumptions go. If nitrogen's not mentioned, assume that you have plenty of it in order to make this reaction happen. We call these mole-to-mole conversion problems using the stoichiometry of the reaction. And this mole-to-mole relationship we've seen earlier, this is a very important relationship in chemistry.